Alright, this podcast has to do with two different types of compounds. And really, we're going to make a little T-chart, and there's two big categories. There's either ionic compounds, or there's covalent compounds. We've done a lab kind of related to this, what their differences are. When it comes to naming, next week we're going to see that they're named differently, but they're really completely different compounds. So they're named differently because of their characteristics. Alright, so again, we're just going to make a T-chart and kind of some similarities and some differences in the way we might name them. So the first thing is ionic compounds form due to attractions between ions. Form due to attractions between positive and negative ions. Okay, so we're talking about ionic compounds have ionic bonds, and those bonds form due to attractions between positive and negative ions. Form between metal elements and non-metal elements as well. Between metal and non-metal elements. And what we're going to see in a little while is that non-metal elements are typically negative ions, and metal elements are typically positive ions. Their structure is they form crystal solids. Alright? Crystal solids. And because they're crystal solids, they are hard and brittle. And brittle just means if you were to hit it with a hammer, it would kind of shatter into lots of little pieces. If you were to think of salt, if you hit salt with a hammer, a bunch of salt cubes, you just break them into a lot smaller salt cubes. So they're crystal solids, they're hard and brittle. They have really, really high melting and boiling points. So very high melting point, we're just going to abbreviate this MP, and boiling points. They have really, really strong attractions. Because their attractions are so strong, it's going to take a lot of energy to break them apart. Alright? And lastly, is that these things typically dissolve in water. So even though they're bonded together really, really strongly, it takes a bunch of energy to break them. If we put them in water, they separate really, really easily. So typically dissolve in water. H2O easily. And a great example of ionic compounds is NaCl. Alright, so it's sodium chloride, and this is simply table salt. Okay? And it's a really good example. If you have that in mind, obviously it's going to take a lot of energy to melt table salt. It's a crystal, it's hard and brittle. And if we look at this, when we get here in a day or so, or actually the next podcast, sodium is a metal. It's on the far left of the periodic table. And chlorine is a non-metal. It's on the far right of the periodic table. So again, we have metal with non-metal, means ionic compound. Alright, so now we're going to contrast that with covalent compounds. Alright, in these there's no ions, but they form by sharing electrons. So there's no ions, that's why it's not called an ionic compound. There's no ionic bonds, like in covalent compounds. But covalent bonds form by sharing electrons. And they form between two nonmetals. So again, they form between two nonmetal elements. They form between two nonmetal elements. typically their structure, they're not real hard like crystal solids, but instead they are often flexible and soft. A good example for this would be wax. So if you think of wax, it's very bendable, soft. Whenever it burns, it kind of melts and flows. It's not going to ever crack and shatter and break. This goes right along with our next one. They have low melting and boiling points. Alright. And what else? Because of that, these things are often times they're gases. Oftentimes they're gases, and I think that's really about it. So again, they form by sharing electrons between two nonmetals. A good example on this one, because the formula for wax is difficult, paraffin, we'll just do water. Again, this is a liquid because it has a relatively low boiling point. So it's a liquid at room temperature, but it's made of hydrogen, which is a nonmetal, and oxygen, which is a nonmetal. So we have two nonmetals with relatively low melting and boiling points. Sometimes they're gases, not always, at room temperature, but that's the difference between ionic and covalent compounds.